So I was looking at the homework of section 4.1 and I realized that there was some that I didn't go over in the lecture part, so let's take a look at some of these. So first of all, when you have an event, you could call that capital A. Like let's say that it's going to rain today. What are the chances that it rains today? Well, in this area, that's going to be about 0%, but let's just pretend that it is 4%. Then if I put a bar over it, that means the opposite. So that means no rain today. And if there's a 4% chance for rain, that means there's a 96% chance for no rain. Another way to look at that is the probability that it rains plus the probability that it does not rain is equal to 100%. Now this could also be written in decimal form, so you could say the probability of A plus the probability of the complement of A is equal to a 1. And then 1 as a decimal means 100%. Okay, so that's what this one is talking about. And if it says the word unusual, that means that it's less than a 5% chance happening. Okay, so then some others. Which of these cannot be probabilities? So a probability would be like 4% chance of rain, 96% chance of no rain. But this cannot go over 100%. So as a decimal, this one would be 0.96. So that is definitely possible. But if it said something like this, that would be a 125% chance that something could happen. No, that's not possible. Negatives? No, that's not possible. And irrational numbers? No, not possible. But at 3/5, that would be 60% chance. So yes, 3/5 is possible. 5/3, that is bigger than 1. So that, yet, not that one. 0% chance of something happening. So what's the chances that I become president of the United States? 0. This would be 7%, so that's possible. Okay, so I'm not going to go over every single one of them, but there are definitely some that caught my attention. And I'm going on to number 6. So the odds. So for odds, you can, so they said that the odds are 69 to 31. So another way to write it is with this little colon right here. And then the odds in favor of it getting second place. So in other words, if you add these together, that's a total of 100. So basically, if this particular horse ran a race 100 times, then 69 times it would get second, and 31 times it would not get second place. I don't know why they're fixated with second place, but that's what they said. So then create a probability out of this. Now you have to make sure that express the indicated degree of likelihood as a probability between 0 and 1. So the likelihood of it getting second place, so that would be 69 over the total. And the total would be the total of these two, which happens to add up to 100. So that's going to be 0.69, or if you want to use a calculator, 69. The glare on that is horrible. Let me try to, ooh, well, that sort of works. 69 divided by 100. So that's going to be a 0.69. Okay, now I need to adjust it again. Okay, so then that would be 0.69. Now, when you come to this question, if you've watched this video, don't just write this as the answer, because they're going to change the numbers for all of these. They have basically the same question, but they change the number each time a different person opens it. So make sure you use the proper numbers. The next one that I circled is 8 right here. You're certain to get a number or a face card when selecting cards from a shuffled deck. Okay. Hold on. I've got a little prop right here. Just happens to be what I use to hold up my calculator. They're saying that you could get a number or a face card. That's the Joker. Hold on. They're saying you could get a number or a face card. All right, that's what they're talking about. Not exactly sure what they're asking. Express the indicated degree of likelihood as a probability between 0 and 1. Well, they said certain. That means you're 100% certain that if you get a card, it's going to be a number or it's going to be a face card. So the word certain is the key. I actually didn't even need the cards for that. As soon as they said certain, that means 100%. And then I just got that one wrong. Why? Oh, they said put an integer or a decimal. I thought they wanted just a decimal. So with this one, they allow you to put either. So you could put 100%, or as a decimal, it would be 1.0. Make sure you always read that part. And like that, 3 decimals for this one, 2 decimals for this one. The next one is number 9. So this is, before somebody gets a job, they have to take a drug test. And what they're talking about is, in here, the probability of a false positive. So a false positive means that the person does not use drugs, and yet they got a false positive test. So they do not use drugs, but the test was wrong, and it said that they do use drugs. So what's the chances of that? Well, these are the positive results, and this one person right here, they do not use drugs, but the test said that they do use drugs. So that means it's going to be 1 divided by the total. So then, what's the total? Can you see it? Hopefully, because I don't want to have to change back and forth on the exposure every time. So that equals 90. So 1 divided by 90 is a 0.011. Then let me see how many decimals they want. Oh, they want 3, and I've got 3. So 0.011. Now, as a percent, if you move the decimal over by 2, that would be 1.1%. And since that's less than 5%, that would be considered unusual. So it is unusual that somebody would get such a test. Who would suffer from a false positive? Well, this person right here, because they don't do drugs, and yet the test said they did drugs, so they totally got ripped off. And then another one that caught my attention is number 11 right here. So there's 450 people. 10 of them were in a car crash. So the probability that a person, and this age bracket doesn't really matter because it's the same everywhere. So the probability that a person would be in a car crash. So that would be 10 got into a crash out of 450. So how much is that? So 10 divided by 450, that is 0.022. Or if you make that into a decimal, move the decimal to the right, so it's 2.2%. And because that's less than 5%, that would be considered unusual. So it is rare, or it is unusual. Type an integer or a decimal rounded to the nearest thousandths. So this would be tenths, hundredths, thousandths. So this is actually asking for 3 decimal places. 0.022. And as long as you put the decimal point, you could put the 0 that goes in front, or you could leave it off. They both mean the same thing. Now you got to watch out for questions like this. Would it be unlikely? So they're asking a question in the negative sense. So would it be unlikely? So yes, it is unusual. So yes, it is unlikely. So is the probability high enough to be a concern for those people? So in other words, if you're in this age bracket, should you walk around worrying about being in a car accident within the last year? Well, it only happens to 2.2% of the people, so I would not say you really need to worry about it. How about number 12? So they're basically saying that these people, or a couple, has a first child, a second child, and a third child. And then they wrote out all the gender combinations. So they could have 3 boys, maybe the first 2 boys, or the first 2 kids were boys, and then the third was a girl. Or maybe the middle child's the girl, or maybe there's 2 girls and a boy. So they wrote out all the possibilities. Now what do they want? So there's 8 possibilities over there. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, they weren't lying, there's 8. Now what if there's going to be exactly 1 boy? So which ones have exactly 1 boy? So this family has exactly 1 boy. This family has exactly 1 boy. And this family has exactly 1 boy. So that means that it's 3 out of 8. So type an integer. Well, that's not an integer, that's a fraction. Or a simplified fraction. So this can't be reduced, so it's going to be 3/8. And again, keep in mind that they might change the question. It's not going to be exactly the same, but it's going to be very similar. And then on to number 14. So this roulette wheel has 28 slots. It's got the number 0, another one that's double 0, and then they have the numbers 1 through 26. So 26 numbers, 27, 28 total. You place a bet that you're going to get an odd number. So this is an even number, this is an even number. So how many odds are there between 1 and 26? Well, from 1 to 26, half of them are odd, so that's 13 that are odd. So that's 13 out of the total 28. And 13 out of 28, so 13 divided by 28 equals a 0.464. 0.464. Type a simplified fraction. Oh, so they didn't want me to divide it. 13 divided by 28. So what are the odds against winning? So odds, they actually put it right here. You put the little colon, and then the odds against winning. So in other words, this was winning. So 13 wins out of 28 trials. That means if you subtract 13 from this, so that would be, how much is 28 minus 13? That would be 15. So 15 wins out of 28, that's to lose, because they said against winning. So in other words, losing. So the odds, so then because they asked about lose, you would put that first, and then over here would be win. So losing would be 15, winning would be 13. When you bet, the payoff is 1-to-1. So in other words, if you bet $1, you're going to win $1. So if you bet $10, you're going to win $10. Now for the challenging problem. How much profit should you make on your $10 bet if you could somehow convince the casino to pay you the payoff odds? In other words, they pay you this way. So this could also be written as a fraction. 15 losing to 13 winning. And then x to 10. So then multiply both sides by 10. And then that's what x would equal. So 15 divided by 13 and multiplied by 10 is $11, and if you round it to cents, that's $11.54. Round to the nearest cent, so $11.54. All right, so I hope that helps with homework on section 4.1.